Hello everyone, myself Dr. Rajesh Prasad, working as professor in CSC department at Akgec Ghaziabad. So I'm going to discuss normal form in context-free grammar. We know the CFG and how many two types of normal forms we have. One is Chomsky normal form and other is Greibach normal form, right? So yes, so this is the content which I am going to discuss. We'll talk about null production first. Because for Chomsky normal form, a grammar must be free from null production. We call it lambda production sometimes, right? Yes. So, and it should be free from unit production also. So that means for CNF, you must remove the null production, you must remove the unit productions, right? And then come to the CNF, Chomsky normal form. This normal form was actually introduced by the Chomsky. And then after Chomsky normal form, you had we will study the Greibach normal form. So for Greibach normal form, a grammar must be in CNF, right? So this is the outline. So null production, as we know that null production, any production of the form A goes to lambda, right? Or we call it A goes to epsilon. Any production of this form is called null productions, right? So such type of production, they have no role in language derivation. So that's why it is advised to remove the null production. Second thing is storing null production in computer is also not easy task, right? So like here, suppose I'm writing like A goes to BC, CFG, and let's say A goes to small a, right? And let's say B goes to small b and lambda, right? And let's say C goes to small cr lambda, right? So question is that how many lambda productions we have? One lambda production directly B goes to lambda. So B goes to lambda is direct lambda production. Second lambda production is C goes to lambda, second lambda production. Okay. So since B and C can derive the null string, therefore A goes to BC. Look at here. If B derive lambda, so it will become C. Replace B by lambda, right? And then replace C by lambda, so it will become lambda. That means A goes to lambda is also a lambda productions, right? So we have three lambda productions over here. A goes to lambda, B goes to lambda, and C goes to lambda. So how to remove the lambda production? Any occurrence of these non-terminals B, C, or capital A in the right hand side is going to be replaced by the lambda to get the new lambda, a new productions rule. For example, see this, A goes to BC, right? This will remain as it is and small a. Now B is lambda, so it will give you C, replace B by lambda. Similarly, replace C by lambda, it will give you B, right? Okay. And then there is no A in the right hand side, so there is no issue. And next is like B goes to B, lambda is going to be removed and C goes to small c. So this is grammar without lambda. So for Chomsky normal form, such type of grammars are most suitable, right? Yes. So this is for example, another grammar. Look at here. This is the grammar like S goes to A, yes, remember, note number, another note you need to remember. If S goes to lambda is a production, right? Then lambda is also part of the LG. Okay, because and then you cannot remove this production rule. Yes, to lambda cannot be removed if lambda is part of the language, right? Yes. So yes, so here S goes to AS or is capital A capital B, then A goes to lambda, okay, and B goes to lambda, right, and D goes to B. Now if you look at here, so the question is that construct a grammar given without null production. That means LG minus lambda we need to produce here. Look at here, A goes to lambda, right? B goes to lambda. They are direct lambda production, clear? So once they are direct lambda production, so you need to remove it. So what will be the alternative? Okay, A is lambda, B is lambda. So if you put right hand side A and lambda, A lambda, B lambda, so by that one S goes to lambda is also a lambda production, right? So you need to remove them one by one. So S goes to capital small a capital S. Since S is lambda, so this will become A, right? Yes. And now AB will remain as it is. Since A is lambda, so it will be A will be lambda. A is lambda, so it will be B, and B is lambda, it is A. And whenever A and B both are lambda, S goes to lambda. So we are going to remove because we are interested in LG minus lambda, right? So S goes to lambda is not going to be included. This is deleted, and D goes to B. So this is the grammar without lambda production, right? Yes. So this is another example. You can go through this. This is the one. A goes to, let us identify the lambda production first, right? So B goes to lambda and C goes to lambda. So whenever B goes to lambda here, okay, and C goes to lambda, both are lambda. So what will happen? B goes to lambda, C goes to lambda. So by this, A is also lambda. Look at here. A goes to BC, B lambda, C lambda. So it will become A lambda. So that means A, B, C are lambda productions, right? So such type of production will be deleted. So what will be the new production rule? S goes to A, B. Remember to write the old productions. We cannot delete the old production. A goes to lambda, it will become BAC. B goes to lambda, it will become AC, right? And now C goes to lambda, right? So A, B is small a. After doing this, just we replace individual by lambda, then we replace in the pairs, right? Since 3 lambda productions are there, we replace in the pair. So once A and B are lambda, we get small a capital C. A and C are lambda, we will get capital B small a, and A and C. B and C capital A small a, right? So AB, AC, BC, right? And then BC become like AA, and then all are lambda, so it will become small a, right? See this? A lambda, it become BAC, B lambda, it become AAC, C lambda, it will become ABA. Now replace 2. AB lambda, it become like this. AC lambda, it become like this. BC lambda, it become like this, right? And then all are lambda, it become like small a. Next one is like A goes to BC, okay? And now B is lambda, it will become C. C is lambda, it will become B. Both are lambda, we are not interested in. A goes to lambda, right? So it is finished, okay? Now this is B goes to small e, C goes to capital D, and D goes to this small d. So this is grammar without lambda productions. So similarly, let us understand unit production. Unit production is very easy. Any production is of the form A goes to B, right? One or more line is known as unit production. And remember, such type of production, they have no role in language derivation, because if A goes to B and B goes to C, C goes to small d, so of course A is going to B, B goes to C, so A goes to D. So if you remove this lambda unit production, A goes to B, right? And B goes to C, C goes to D. So of course A goes to D, right? So that is the answer. That means A goes to D. This is removed completely. Similarly, B goes to C, C goes to D. So this is removed. So B goes to D. And then C goes to D. So this is the grammar without lambda productions, right? Yes. So this is another example, like see here, S goes to AB and A goes to small a, B goes to capital CB, C goes to capital D, D goes to capital E, E goes to capital small a. So of course, you can see that this is not this is not a unit. There are two non-terminals, so this is not unit, right? And this is also not unit, but this is unit. B goes to C is unit, right? So what is replaced in place of this? B goes to C, okay? C goes to D, D goes to E, E goes to A, so B goes to small a and small b. This is grammar without unit production. This remain as it is. S goes to AB and A goes to small a, right? Yes. Similarly here, if you go by this, C goes to D, D goes to E, and E goes to small a. So this C goes to small a, right? Similarly here, D goes to capital E, capital A goes to small a, so D goes to small a, and this goes to A. So this is the grammar without having unit productions, right? Yes. So remember, for unit production removal, make sure that there is no lambda production. So you have to remove lambda production first. Then whatever answer is coming, you start removing the unit productions, right? Yes. So this is the very important normal form. We call it Chomsky normal form due to Noam Chomsky, right? So this is very simple. Remove start symbol from right hand side. Remember, there should be no start symbol in the right hand side if you want to get the Chomsky normal form. No lambda and unit production. So this is step number 1. Make sure that the starting symbol is not in the right hand side. Number 2, make sure that there is no lambda and unit production. Third one, there is no useless symbol. Useless symbol means that a variable should not be like non-active and variable should not be non-reachable, right? Yes. So there should be no useless symbol, but there are no lot of no restrictions given on this. Even it is acceptable, but this should be the primary condition. Even if a grammar is having little bit useless, so there is no problem, right? Yeah. So question is that, So suppose this is the grammar. S goes to small a, capital D. A goes to small a, capital B, or B capital AB, right? And B goes to small b, D goes to small d. So what is Chomsky normal form? Chomsky normal form, any production of the form A goes to capital 2 letter or small letter, where A and B and C are member of non-terminal, A is member of terminal. So that means that any grammar is in Chomsky normal form. If this is satisfying this rule, A goes to capital B, capital C or small a, right? Now, two non-terminals are a single terminal, right? So of course, you see, this is in Chomsky normal form because this is satisfying the criteria. This is also in Chomsky normal form. This is satisfying the criteria. But this is not Chomsky normal form. This is not in CNF. This is not in CNF. This is not in CNF. So what is construction? Construction is saying that, okay, those who are not in CNF, no problem. We introduce a non-terminal corresponding to terminal symbol, right? So what you are going to do, like see here, let us introduce Chomsky small a. Like this is a non-terminal which is replacing small a, and then capital A, capital D. A goes to C A, capital B, or CB, capital AB. Are you getting my point? See, we introduce small a, capital A for small a, and capital B for small b, CB for C, CA for small a, and CB for small b. So this is now transform grammar. Okay. So now CA was A and CB was B. That is it. Simple. Okay. Yeah. And now B goes to small b, D goes to small d. Yes. Right. Yes. So now if you can see this, this is like additional. There is no effect on the grammar. since C was introduced, so CA is replaced by small a, CB is replaced by small b, right? Okay. So now here, what you are going to do, take this right hand side also, take this one as any non-terminal, right? So what you will do, S goes to CA, let's say this is Z1, and send Z1 to A capital D. Simple, right? Similarly, A goes to CAB or CB, and let's say this is Z2, okay? And don't forget to send Z2 to capital AB, right? Yes. So now you see CA goes to A, CB goes to B, B goes to small b, D goes to small d. So this grammar is in CNAF. So please note that, if you are having production like A goes to A, B, C, D, E, right? Okay. So what you are going to do, you can take this one as a non-terminal Z1, or equivalently, you can also take this as a non-terminal, anyone which is suitable to you, right? So suppose like this one is A, then Z1. Don't forget to send Z1 to B, C, D, E, right? Yeah. Again, this is in CNAF, but this is not in CNAF, okay? What you are going to do, take it as a Z2, okay? So Z1 goes to B, Z2, and Z2 goes to C, D, E. Okay. Again, this is not in CNEF. So what you should do, this is the one. Okay. So Z2 goes to C, Z3, and Z3 goes to C and D and E. So this will become in CNAF. So this is very simple thing, right? So to understand the CNAF. Okay. So this is, you can also check like this. This is a simple example, just like introduce, S goes to small a, capital A, small b, capital B. Okay, and capital A, small a, capital A, or small a, capital B, small b, capital B. So it's very simple. Remember, like, if you just like see that this is not having unit production, this is not having lambda production. So no need of going to remove the lambda and unit production. Okay. So what you are going to do this here, S goes to CA, make a non-terminal for this, and then A, and then CB, capital B. Okay. And then A goes to, we already introduced CA and then A. No need to replace this. Remember, no need to replace this because this is already in CNAF. Okay. Then CB and B, then B. Clear? Now, same thing. This guy is in CNAF, this guy is in CNAF, this is in CNAF, this is in CNAF. Only S goes to, this is not in CNAF, this is not in CNAF. Okay. So what you are going to do, S goes to CA, take it Z1, okay, take it Z1, and then Z1 goes to ACB, capital B, okay. Rest is already there, this is in CNAF, this is in CNAF. Now, again, this is not in CNAF, so this guy is okay, it is in CNAF, okay, but this is not in CNAF. So what you are going to do, this is in Z2, make it Z2, okay. So Z1 goes to AZ2 and Z2 goes to CB and capital B. Okay. So this is now in CNAF. So it's very simple construction. So next normal form is Greibach normal form. Remember, most of the literature for Greibach normal form are ensuring that grammar should be in CNAF, right? So what is production rule? Just like in CNAF, each production rule whereof the form 2 capital or 1 small. Similarly, in Greibach normal form, each production rule should be a small letter followed by non-terminals. X belong to V star, right? So every terminal followed by any number of non-terminal, or it could be epsilon also, right? For example, if somebody is saying that whether this grammar is in GNAF or not, A, B, C is small, capital A, yes, right? And yes, and B goes to small b. Yes, this is in Greibach normal form. Look at here, a small letter followed by sequence of non-terminal or single terminal. So Yes, this is correct. That grammar is in GNAF. So, how to check whether grammar is in GNAF or not, right? So, there are two lemma. Lemma number one. Lemma number one is saying the substitution rule, right? Substitution rule. What is this? If A goes to, let's say, alpha B beta, okay, right? And B goes to gamma 1, gamma 2, up to and so on, gamma n. Then they are saying that remove this and replace A production by alpha B. B is gamma 1, then beta. Again, B is gamma 2, alpha gamma 2, beta. And B is gamma 3, alpha gamma 3, beta, like this. Yes. And this remain, this will be removed. This is lemma number one. Lemma number two is of course related to left recursion, right? So if you have production of the form A alpha 1 or A alpha 2 or A alpha 3 dot 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 A alpha n, right? Yes. And A alpha 1 or like you have like let's say beta 1, beta 2 like dot 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 beta m, where each beta is not beginning with capital A. Beta is not beginning with capital A. Okay, yes. So what you are going to do, remove this A production and write down the additional production. Remember, this will remain as it is, beta 1, beta 2 and so on, beta m, and attach another non-terminal together with them, B1 beta B, B2 B and so on, beta m. Yes, okay, B. And B goes to alpha 1, alpha 2, right? Yes, alpha n, and attach this capital letter with them also. Alpha 1 B and alpha 2 B is very simple with them, right? This is the lemma number 2. Yes. So the this is lemma 1, this is lemma 2. So sometime we need lemma 2, sometime we need lemma 1, depending on the situation, right? So suppose you have like a grammar, let's say S goes to A or small A goes to S or small b. Okay. Suppose this is the grammar. In this GNAF construction, we used to rename, let's say S is A1 and A is A2. Okay. So we used to rename the symbols. After renaming them, what you are going to get? You are going to get A1 goes to A2, A2 or small a. Okay. And A2 goes to A1, A1 or small b. Here, we used to check indexing of this, right? So 2 greater than 1 and this one is greater than less than 2. So we are trying to like work on this, the number which is less than. So replace A1 by this number, right? So what you are going to get, A2 production will be just replace this A1. So if you replace A1 by like A2, so A2, A2, then A1, okay. Or A1 is replaced by small a, so it becomes small a capital A. We are working on A2 production or B. Now look at here, this becomes the same, 2 equal to 2. Yes, that means this is going to use lemma number 2. This was using lemma number 1 for substitution. Okay, now this is 2 equal to 2. Is okay. So this is alpha 1, this is beta 1, this is beta 2. Okay. So what you are going to change, this GNF A2 goes to beta 1, right? A1 or B, and then attach another non-terminal with them, A1 B2 or B B2. Okay, yes, okay, yes. And now B2 goes to A2 A1 or okay, or B A2 A1 and B2. So now you can see that this is already in GNF. Okay, this is already in GNF. A2, yes, GNF. Now, if you look at here, A2, A1 are like this. Okay, Now, if you look at here, A2 is in GNF. Okay. If you replace this A2 here, A1 will also be in GNF. Remember to replace only this. Similarly, if you replace this A2 here, B2 will also be in GNF. So you will get the complete GNF. Okay. So these are the references. Thanks for watching.